first question will be reverse array. Reverse array. Right? So reverse array takes an array. So what you needed to do was return a new array of the input array reversed, and not to mutate the old array, okay? So if you were taking this array and trying to shift or pop things off and push them back in, something like that, in that array, that's a no, okay? Because that is mutating the original array. So what we wanted to do was create copies. And what's an easy way to make a copy of an array? Slice. Okay? So we know we want to do this recursively, but let's think about how we would do this normally, right? Normally, we would make our result array, right? Like, let new array equal this. Then we would do a for loop starting from the back of that array, push everything into that new array, and then just return the new array, right? That's so simple. So let's make it a lot more complicated, right? So before we do this, before we do anything else, we should think about our base case, because I told you like 55 times yesterday to start with your base case. It's hard to think about what your base case should be, so think about what your problem itself is returning. The problem itself should be returning an array, right? So our base case should probably be returning an array as well. So we have that. So what would be a good case, right? If the length of the array is 0 or 1, right? Because 1, nothing else is going to come after that, so we could just take that array and we could toss it up, right? So we could do if array dot length is equal to 1, we can return array dot slice. Why am I slicing? Because it's making a copy, okay? Each iteration, each recursive call, we want to make a copy of what we're actually doing, right? So, now that I've handled this case up here, let's start thinking about our recursive case. So the first thing is that we need our last element, right? So right now on our first call, like if I'm calling this with an array of 1, 2, 3, right? First thing we need to do is we need to take this 3 and put it in this. We need to push it in there, right? Because that's our first step to reversing. So we take the last element and we do new array dot push array at array dot length minus 1. Array at array dot length minus 1 will be the last element of the array, no matter how long it is. Okay? And we push that element into this array. Cool. So now our new array has one element. So now we need to make our recursive call. And this was the tricky part. So we know we have to add something together, right? Like, it might not seem it, but we do need to add things together. We need to concatenate multiple arrays. Because what we want to add onto now, the back of this new array, which will contain this 3, we need to add on to the back the 2 and the 1. So we can just simply do let remaining will be equal to reverse array. And what we're going to pass in here is array.slice, because we have to make a copy of it, array.slice from 0 to -1, or array.length minus 1. But with slice, we could just pass in -1, okay? Then we could say new array dot new array equals new array dot concat remaining. Nope. Remaining. Okay? Then at the end, we can return new array. So, let's see. Well, let's just leave it. Okay. Let's see what the call stack looks like. Wow.
I think you erased. Did you mean to erase that? The array dot slice?
What?
Mine.
Oh, my bad. I did not mean to do that. Thank you for letting me know. So let's see what the call stack looks like when we throw in this array of 1, 2, 3. First, let's see if it works. Yes. Okay, cool. So let's see what happens when we throw in reverse array of 3 of 1, 2, 3, right? This goes on the call stack. So we have to see what happens. So if the array.length is equal to 1, it's not, so we skip here, right? And we make our new array, and we push in array at array.length minus 1. So does everyone agree that we are now pushing in the 3? Right? So we are now going to, well, let's skip this step here. Well, it's fine. We could just do this, right? And then we can we could chain that together too, but that's too confusing. So now we go on to the next step, and we have new array. We declare that. We push in the 3, and then we say declare this variable. So we declare this variable to a function being invoked. It happens to be the same function we're inside. So this is a recursive call, right? So what are we actually calling? We're calling reverse array, but we're passing in the array, the original array, dot slice of 0 to the last element. So we're not including the last element. So what we pass in is 1, 2. Okay? We do the same thing again. Is the array.length 1? This is now paused, right? Does everyone agree that this is paused, right? So now, let's run this and see what happens. Is it 1? No. We declare this, and now we do new array.push array at array.length minus 1. Now, since we sliced off the last element in our prior call, now 2 is the last element, right? So now new array has a 2 inside of it. Then we say let remaining equal reverse array at array.slice. So we have another function call. So we do a reverse array of just a 1, right? Because we are passing in array.slice, and array in this situation was just 1, 2. Array.slice of 0 to -1, not including the end, start at the beginning. So we throw in 1. Array.length is 1. So we hit our base case and we tell our function to stop. So this returns array.slice. So this returns 1, a different array, okay? A copy, right? So now we know back in this problem, we were waiting to see what remaining was, right? We called this with array at 1. So remaining equals an array with just 1 inside, right? And then this will now return. So we can take this off the call stack because that just finished running. And now this returns new array, which is 2.concat remaining. And remaining is 1, right? So this returns this. So if this returns this, the whole time the original call, which was paused, which is still paused until now, is waiting to see what remaining will be in its situation when we passed in 1 and 2, right? So now that we know what remaining is, because this returns 2, 1, so that means remaining is 2, 1. So we could take this off of the call stack. And this will return array of 3, because that was our last element there, .concat of array of 2, 1. Because that is what remaining was in our situation when we passed in 1 and 2, right? Oh, shit. Right? So this concatenated will be this. So that's why we see 3, 2, 1 over here. And then we finally take this off the call stack. Any questions? This was definitely tricky because you're working with arrays now, right? Like numbers are one thing. Like that factorial problem, that's one thing. You know, even strings, that's another thing. But arrays get tricky because you have to think about if you're passing, because remember, pass by reference, pass by value, right? That's not just based off of assigning. That's also passing it into functions. You pass references into functions, right? So if you're using push and pop on the original thing, things are going to get really messy, okay? Okay? Okay. So, enough of this. Now we will do, what are we doing? We're doing, oh, is palindrome. Okay. Is palindrome. So is palindrome is a little tricky. Do you guys remember, do you remember is palindrome from the loop workshop? Yeah? Go back and do it and solve it normally and see how easy it is, right? And then try to think about how hard you struggled with it on the second day. And look how much you've learned. And you'll feel better about yourself, okay? It's a nice pick-me-up after you do it the recursive way, you know? So anyways, so is palindrome, we want to check if the input string is a palindrome. So a palindrome is every letter, if it's like every letter is equal from frontwards to backwards, right? So if you reverse it, it's the same string, okay? So right away, we know we need to solve this with recursion. So right away, we need to know what our base case is. So you might be saying if the string has no length. Well, that's not true, okay? That isn't actually our base case. We know that we will be comparing the first and the last one, right? That's just how you have to do it. That's what palindromes are, right? The first letter has to be equal to the last letter. Because if they're not, you could just stop and return false. But if they're true, then you go one place in on both sides. And you have to keep comparing them as we go in. So we actually have two base cases because depending on if our string is even or odd, has an even or odd length, right? So if we can do, well, the first thing we could do is we can make sure that we're not dealing with capitals. So we could just do string equals string dot to lowercase, right? So we could just do that quickly. And then we could say our first base case, right? If string dot length is equal to 1, and if you think ahead, that means we'll be going down and down, and we finally hit that 1. So that means if we never return false up until this point, we can just stop. We can just return true, right? Does everyone agree with me? Like, if we're on that middle letter, like, everything else must have been good, so we can return true. Now if there's 2, so now we can do if string dot length, if string dot length is equal to 2, we can return, what do we have to return? Do we return true? No. We actually have to make this check. If the string length is 2, that means we had, what is that, an even number of letters, right? So if we had an even number of letters, then we have to compare the last two, string at 0 and string at 1, right? So we could just return string at 0 is equal to string at 1. We could do if string at 0 is triple equal to string at 1, return false, else return, if it's equal, return true, else return false. But this already returns a Boolean, so we could just say return that, right? Does that make sense? Does that make sense? Cool. So these are our base cases, okay? So now we have to start thinking about how we can recursively call is palindrome until we hit our base case, right? So what can we do? The first thing we have to do is we have to check. We have to check if the first two letters, and by first two I mean front and back, if those are equal or not, right? So we could say let first equal string at 0, and we could say let last equal string at string dot length minus 1, right? So then we could say if first is not equal to last, we can just return false, right? Because we don't have to make a recursive call. If they're not equal, don't make a call, because we can stop. We don't have to check anymore, right? Because if these two aren't equal, then it's impossible for the string to be a palindrome, right? If the last two are not equal, stop the function and return false. If this isn't true, right? If we make it past here, as in first is equal to last, we have to return something else, right? We have to return our recursive call. Return is palindrome, and we have to pass in string dot slice 1 to -1. Because string dot slice of 1 to -1 starts at the first index, so we don't include the 0th index. So that first letter will be gone. We're not passing that in. And we're also doing -1. And with slice, the -1 will be at the end. And it's not inclusive. Okay? So that means if we passed in like mom into this string, and m is equal to m, so this doesn't run, then we pass in, we slice off the first m and we slice off the last m, so we pass in that o, right? And then we finally hit our base case and we return true. So this will return true in that situation. And if ever we get down closer, if ever we hit that false, you can actually think of that as a base case as well. You can think of it as a base case, right? Because if they are not equal, just stop looking, right? If we solve this, if we were using a loop and we were checking, we would stop the loop, right? We would break out and just return false. You wouldn't even use the break keyword. You would just return false, right? Stop the entire function. This is false. Does this make sense? Yeah.
So for the second condition,
Here?
Line 19.
Here?
So let's say I pass a string of Anna with double N.
Okay.
Is that when that line?
Right. So if I pass in Anna with two n's, A is equal to A here, because we don't do this right now. A is equal to A, so this doesn't run. So we pass in, we slice off both of those A's. So then we have NN, right? String.length is equal to 2, NN, right? So we return string at 0 triple equals string at 1, NN. So N is triple equal, so we will still return true. If we misspelt Anna and we had like,
1N, that's for type 17?
well, one N would be here, right? But if we had like A-N-H-A or something, right? We misspelled Anna. Then string at 0 would be the N, and string at 1 would be H. So that would return false, right? Any questions?
So that return string at 0 and equals string at 1 handles both the false case and...
Yeah, because we can do like if string, we could do like if string at 0 triple equals string at 1, we can do like return true, else return false, right? Mm-hmm. But like the triple equal operator, that returns a Boolean, right? So if that returns a Boolean, we don't have to say return true, return false, because it reflects that, right? So we can just say return what this returns, what this equation returns, right? We return what string at 0 is equal, triple equal to string of 1 returns, okay?
Is that a true feed? That the return string 0 equals string.
This?
The line 18, the last part, the return part of the line 18.
What do you mean by is this a true feed, Chuck?
It's like what we used, and we made it, because you're saying that you will return both. Either, I mean, you will return one.
So this is going to return a value from the function, right? This isn't looking for truthiness, right? This is looking for truthiness. The string.length is equal to 2. That's looking for truthiness. Like if we passed in, if the string had 3, then that would be false, right? And false is falsy, so we would keep going. Cool? Okay. More recursion. Okay. So now what am I going to do? So now I'm going to show you how to recurse through like multi-dimensional complex types, like arrays or objects. I'll do one of them since the slides go through both. So I'll do one of the examples live because it's kind of like a pain for both of us, okay? So let's say I wanted to write a function called getSum, okay? And getSum takes an object, right? And let's say our object we define here. We have A will be 5, B will be 6, C will be an object with D, which is also an object, with E, which is also an object, with F, which is 10. And then after C, we'll have X, which is 100. Okay? So we have like a ridiculously stupid looking object, right? Which no one will ever want to deal with ever, you know? However, let's say that for some reason in our program that we're writing, we don't know how many levels down this F will be, right? So we can use recursion to find out when exactly to stop, right? So if we wanted to get the sum of all of these values, right, we would have to make checks to see like, okay, is this an object? If it is, we can do another for in loop, right? If it's not, we can just increment our sum variable, right? But if it's an object, we can't just do that. We can't do sum plus equals object, right? So what do you guys think, just by looking at this, without even thinking about the logic of solving the problem, what would be a good place, what would be a good thing for our base case?
Length of the object.
No, objects have no length property.
How many keys there are.
No.
The type of object. Here's object, right?
That's the recursive case. But when will we tell our recursive case to stop? It's pretty much the opposite of that, right?
It's not enough.
Right. If it's a number, we don't need to call it recursively. We could just add it to the count, right? Our sum. So that will be our base case. Our base case will be if the current value, like, because this is the whole thing is an object, so we're going to do a for in loop for sure, right? We have to loop through the outermost object. However, if we call our function again, that will only be if the current value of the key value pair is an object. If it's a number, we can just add it and we don't call it recursive. Let me show you what I mean. So like our function here, the first thing that we would obviously do, we would say let sum equals 0, right? Because we are returning a number and this is our counter variable, our sum storing variable, right? So obviously, we know we have an object. We know we're dealing with an object. So we do a for in loop. for sure, okay? I know, like, you're thinking, oh, but recursion, you don't use loops in recursion. No. So we still have to actually loop through this object, right? Yeah, that's exactly. Every time like someone asks me a question, that's like, no, I'm just kidding. So basically, we loop through our outermost object, right? So let me just pull this out so it'll be easier to read, right? So we say let current value equal to obj at key, right? Well, I'm just going to change this to obj because I don't know why I wrote objects in the first place. So the current value will be obj at that key, right? Does that make sense to everybody? Cool. So now we have to do some decision making, right? We have to decide if we want to call our function again or if we just increment. Okay? So if type of current value is equal to object, we're going to do some stuff. But else, if it's not equal to an object, we will just do sum plus equals current value, right? Like if it's not an object, we'll just put it in here, right? But if it is an object, what do? We still have to increment sum, right? We still have to do that. So we do sum plus equals, but then we do get sum, and we just pass in the current value. Then at the end, we just return our sum. Right? Let me walk you through the call stack so you can see what's actually going on. Because this is like a pretty simple solution, but like I'll bet like $1,000 if I told all of you to do this now, none of you would do it, okay? So, no, I'm just kidding. I have faith. Just kidding. But let's walk through the call stack and see what's going on, right? Because really, this is like annoying to do, like, oh, what's going on each time, But like, it really helps you visualize what's happening. Like you can visualize in your head what recursion does on your own, however you want to. But the call stack, what I do over here, what I show you guys, that is literally what JavaScript is doing. That is what JavaScript is really doing. This is a fact, okay? So you can think about it in your own head however you want, okay? But like, if you do this, you will understand the language better, okay? If you're still struggling with recursion, which I bet 99% of you are, because honestly, like some like full-time developers that I know still struggle with recursion, because it isn't every day that you have to use recursion on your job, but I have come into situations where it's just like you kind of need to, okay? Well, it's not like you kind of need to, it's kind of like doing it iteratively with loops would be more complex. Anyway, so let's say we throw in this object, right? Let's make this one 10 because I don't want to do that much, okay? So we have this object, right? And I'll put this down here so everybody can see it, okay? Sort of. Okay. So the first thing that we do is we call getSum, and we pass in an object with A is 5, B is 6, C is object, with D, which is 10, and then after C, we have X, which is 100, right? So in one line, that's what it looks like, right? Does everyone agree with me? It's kind of annoying to look at it that way, but if you look at it in a line, it's just easier, okay? So what are we going to do? What is this return? Because when you call a function, functions need to return something, right? If you don't tell it to return something, it will return undefined. So it always returns something, right? So what does this return? Let's walk through. We let sum equal 0. We loop through this object, right? For let key an object. Let current value equal object at key. So let's say it is in order, but it's not in order because objects aren't guaranteed to have order. But let's say it is in order. A is the current key, so 5 will be current value. Does that make sense? Does that make sense? Like 5 will be the current value, right? If we're going in order, like mentally. If type of current value is triple equal the string object. Is it? No. So we skip our recursive case and we add 5 to the sum. So let's also keep track of our sum, right? So that's 5. And our return value will be something, okay? So now we will say, now that we say else, sum plus equals 5. So the value, the sum is 5, right? So now we continue our for in loop, right? Like, that was fine. And then we hit this B, this next B right here. So current value will be 6, because the key is B, so the value is 6. Is the type of 6 an object? No. So we skip line 44, we go into our else, and we say sum plus equals 6. So sum is now 11, okay? And we continue our for in loop. Let current value equal object at key. Key right now is C, and the value of C is an object, okay? Is type of current value equal to object? It is, right? So that means everything stops because we go on to 44. So now sum is going to be equal to 11 plus equals 11 plus equals get sum, and we pass in an object with D is 10. Does that make sense? This makes complete sense, right? Like we finally hit that object, so now we're saying sum is going to be plus equal to, because we know we have to increment sum to something, right? It's going to be plus equal to get sum of an object. So it's going to be equal to a function call. So now that we're assigning this function call, this goes on the call stack, right? Get sum of this object, okay? So let's pass in this object and see what's going on. We initiate sum again at 0. New function call, we initiate it at 0, and we loop through this object. Sure, this object has one key value pair, so why should we loop? We don't know how many key value pairs this object will have, so loops are dynamic, right? So, let current value equal object at key, that will be 10, right? So we say, is 10 equal to an object? It's not. So we do sum plus equals 10. So sum equals 10. Does that make sense? So now we're done looping, because this object had only one key value pair. So we're done looping, and as you see, we never hit our recursive call. So that means we return sum. So this actually returns 10. So if this returns 10, we can take it off here, but we were waiting for that value over here, right? So that means that sum, this whole time we're waiting to see, line 44, what it's going to be plus equal to, right? It's 10. So it's 21, right? And then we skip this else. And then we continue our for in loop in this function, because this function is no longer paused, right? And now our next key value pair will be x and 100, right? So then we do the same thing, let current value equal object at key. Key is x, so the value is 100. Current value is 100. Is 100's type object? No, its type is number. So we do not hit our recursive case, and we go into our else, where we make this 121, okay? Then we finished the for in loop. The outermost for in loop is done. So this actually returns 121. Right? Yeah.
So, this is the case for object, but if the last value for D was instead an array.
So if you wanted to mix up arrays, if you wanted to include arrays in here, right,
That's,
you would have to add another check.
oh, I see, if the.
So-
okay.
Think about this.
Oh, but can you say or instead, using two checks?
No, because as you can see, our function, right now, our function is dictated towards objects, right? Right? Like, we expect whatever is going to be passed in recursively to be an object, right? However, if we wanted to change our function to also incorporate arrays, like, oh, sure, our first thing that we're going to be thrown in is an object, but if inside that object there could be arrays, then we would have to change this. We would have to do one loop here and one loop down here. If obj is array.isArray, right? If array.isArray of obj, then we do a for loop. If it's not, then it's an object, so we do a for in loop, right? And that would take care of that case. But we're still adding to sum. It's just how you loop would be different. And you would always check for array.isArray first, because the type of an array is an object, right? So that would be true for both cases. But false if you pass in an object to array.isArray, right? Tricky, right?
Yes.
But not too bad, right? Think of it as kind of like, instead of a base case, we need to figure out when we can skip over our recursive case, right? Because we're not actually telling it to stop. We're telling it when to not call its recursion. We're not telling it to like return something. We're telling it when to like stop. We're telling it when to like skip, right? Like, okay, fine, we finally found something that isn't an object. Let's skip this line, and then we could just continue our sum. But the thing is if you are trying to concatenate values together, like add numbers together, concatenate strings together, you can't, and your function returns something, you can't forget this, okay? I see a lot of people always forget to put that in there. You have to still concatenate what that recursive call is returning with your current sum. You still have to do that. You can't just call get sum. Because if you just called get sum and you didn't do this, then yeah, it returns like 10 or whatever. But then what do you do with that 10? You don't do nothing. You continue your function. So your overall sum would be wrong. It would be 10 less. So you have to remember to get that value and put it somewhere. If you don't put values somewhere, then they're just okay, this is value. It doesn't do anything, okay? Any questions?
Well, so, it is also another way to check according to this. Like, for instance, if you say if object that has own property, and then parentheses.
Yeah, you could do the has own property thing.
Which one is the more useful to us?
I would do it this way because this is more literal.
It's your
Yeah.
They're both same age or?
Well, object dot has own property. If you look up the documentation on MDN, that checks if like a certain key is inside of an object. I'm pretty sure that's what it does. It's kind of like the in operator almost, except there's definitely a distinction that I can't remember off the top of my head right now. But it doesn't check for type. You can kind of finagle that in here somehow, but yeah. So any questions? Any other questions? Okay. Cool. So let me show you some slides, some customized slides. Customize, custom. Recursion dose. So, let's look at this example. So if we have a function logs an array, right, and it takes an array, and we do for let I equals 0, I is less than array dot length, I plus plus, and we console.log array at I, right? And we throw in 1 and then 2, 3. We get in the console 1, but then we get in an array 2, 3, right? So like, what if the input is nested? Consider element on line 3. That could be a number, or it could be another array. If element is an array, we want to log every number inside of it. If only we had a function that takes an array and logs out all of its values. Oh, wait a second. We already have that, right? We need to go into that inner array and log out all its values, but that's already what our function is doing. So why can't we just call the same one again, right? So, this is how we would do it, right? Function logs an array. You loop through this array. You let element equal the current element, right? Array at I. And we say if array.isArray of element, which array.isArray returns true or false based off of that thing you pass into it is an array or not. So if it is an array, we will call logs an array again. Else, we just console log the element. So it's an if else. If the if is not true, we do not call that. If otherwise, we just go into the else and that's it. So let's look at the call stack, right? So the first thing we would do is we would do logs an array, and we would pass in the array of 1, 2, 3, right? So this array has 2 elements, 1 and another array with 2, 3. So then we would call, we would start our for loop on this array, and we would say let element equal array at I, which would be that 1, right? Because we initiate I at 0. We check to see if it's an array. 1 is not an array, so we console.log it. Next, we get to I is now 1. And at the first index, we have an array. So if array.isArray of that element, which it is, the element is the array 2, 3, then we do logs an array again here. It goes onto the call stack, and we pass in 2, 3, right? So we got that 1. And then, since that's inside, now this array is now 2, 3. So element at array of I will be 2. 2 is not an array, so we go into this else, and we see the 2. Then we increment again, and we get the 3, right? Then we're done. This for loop is done. So that means, since that function is done running with the 2, 3, we take it off of the call stack. Customized by me. I forgot to take it off. But yeah, you take it off of the call stack, and then we can finally finish, since we were here before on this call, and that was the last element, we skip the else, there's nothing else to loop through, so we're done. Right? This is a more simple version of what I showed you before, except now we're dealing with arrays, right? Cool. So, here's an example where you concat elements, right? Function concat els takes an array. We let final string equal an empty string. For let I equals 0, you loop through the array. And then you say final string plus equals that element, right? And then we return our final string. So we pass in A, B, C, an array with 3 elements inside of it, the string A, the string B, and the string C. Console.log out result, and we get A, B, C. This makes sense for everybody, right? Simple for loop, adding to a string, simple string concatenation through an array. So, how would we do this if the input array could have nested arrays, right? So we would say let final string equal an empty string like usual. We would do a for loop like usual. We would take out the current element like usual. But now we have to make a check. And if you guys remember, if you did something like this before in, I want to say the Array 2 workshop, if you did this same check there too, when we were dealing with multi-dimensional arrays then, for the first time. You would say if the current element is an array, you would do another for loop. Else, you would just add it, right? This is sort of the same thing, except now we're doing a recursive call. We are adding to the string a recursive call of that element, of that current element, right? So let's look at what happens on the call stack, right? We call concat Ls of A, B, and C, right? And final string is right now an empty string, right? So then we are on A, current element is A an array? It's not, so we go into the else, final string plus equals A, right? So final string is now A. Is everybody with me? Everybody's with me, cool. So then we get to the next element, which is an array, BC, right? That is element is array.isArray of that element true. It is true. So we go into this if statement and we do final, which is A, is now plus equals to a function call. So that function call goes onto the call stack and we call concat else with this array BC. Does that make sense to everybody? Right? Nothing too fishy so far, right? So if we're calling concat else again with the array BC, we initiate let final string again to an empty string. So let's do our loop and let's pull out array at I, array at 0, and that's going to be B. And B is not an array, so we can skip this if statement and go to our else. So we can concat that original empty string with B, right? So now we continue our loop. And we hit the next element, which is a letter C, a string C. Is C in an array? No. So we go to the else and we concatenate it to final string. And final string was B, so now B plus C is BC, right? And now we're done. There's no other elements inside of this array, right? So then we make it past here, and then we go down here. What's the last line? Return final string. So final string is BC, right? So concat else of BC returns BC, right? So that means now that this is returned, we can take that off of the call stack, and this will be equal to something, right? This will now have its value evaluated, right? A plus equals BC. ABC. ABC. Take it off the call stack, and that's that. Does that make sense?
How's the function keeps? Oh, never mind. It's on the bottom. When you say let result equal context, right? It will call the function again and again, and final string will be reset to that thing. However, and the result, that's the I guess it's saving all the letters because of the calculation.
Yeah, so when this would eventually be ABC, and then this original call will return ABC. So result will be ABC.
But is result having all the letters like A and then concatenate B, then C, because the function is called when it finds an array.
Wait, say that again? I don't understand.
Like every time that we make a recursion, the final string will be set to null, to empty, to nothing.
But when we call the function, and we reset it to nothing, right? That function's still going to return something, right?
Right. It's
So that
going to-
return value is going to be concatenated with the
It's-
previous call.
Right, and since it is, we set it to empty string, right? Where is the previous, let's say, where is A being stored or saved?
Your memory.
Right, but in which variable? Is that in which old variable?
It's like back here, like this has its own version of final string, and this has its own version of final string. These are two separate function calls. I know it's the same function, but they're two separate calls.
Right.
So when you call a function, like, do you remember scope, how outside here,
Yes.
if I try to console.log final string, I couldn't? Because it's defined inside function, right? So that means it's initiated inside a function, right? It's initiated inside of concat else. So that means that this has its own initiated final string, this has its own initiation of final string. But these two things return their own initiation, right? So if concat else of this returns BC, the whole time we were waiting for that to be concatenated with what that returns, right? So this whole thing is just paused in memory somewhere, okay? It's just waiting for this to finish running. Because JavaScript can only run one function at a time, right? So that's why this pauses, okay? Cool. Cool. What is this? Okay, yeah, then we get ABs. Cool. So, nested objects. Working with nested objects is very similar to working with nested arrays. You use a for in loop to iterate through the object. And if the value is another object, you recursively call the function on the nested object, right? I just showed you this before, live. So we'll do some vals, which is like literally the same thing that I just showed you, okay? So as you can see, this is a very simple problem, simple solution. You just loop through that object, you take the value, and you add it to the sum and return the sum, right? That works if this is not a nested object. If it is a nested object, we need to use recursion, right? Because we don't know how nested it's going to be, right? Look at this. Look at this thing. Look, we have A is 1, and then B is an object. So this object, OBJ, has two key value pairs. One of them is a number. The other one is an object. And inside of that object, we have another object with one key value pair, which has another object with two key value pairs, E and F. So how do we go down, deep down, and get the 2 and 3 from E and F, right? This is how. This is the same solution that I had before, right? Let sum equal 0, and then you loop through the outermost object. We pull out the current value, and if the type of that current value is an option, we reassign sum to itself plus the return value of some vals of that inner object, right? Else we just plus equals the value to the sum there, right? So let's see what happens when we call it with this ridiculous looking object. It goes onto the call stack, sum is initiated at 0, right? So the first key value pair we get is A, right? So A, its value is 1, so type of value is not object, so we go to the else and we plus equal it to the 0, so now our sum is 1. Does that make sense? Cool. So now the next part, 1 is now going to be plus equals to a sum vals of this object, because the next key value pair is B object, right? So key is B, so obj at key, the value will be that object. So as you can see here, it's C, D, E, F, right? So this goes onto the call stack, right? So now we initiate the sum again at 0, right? And we loop through this object. So our key will be C, so the value will be another object. So we'll go into this if statement, because type of value, which is an object, is equal to object, right? So that means 0 is going to be plus equals to some vals of D, E, F, right? Does this make sense so far? We're looping down and down and down, right? So then we pass in D, and then the key is D, and its value is another object, right? So, since that if statement is going to be fulfilled, sum plus equals another function call. Sum vals of an object of 2 and 3, right? E2, F3. So that has to go on the call stack as well. And we initiate the sum at 0 again, right? Let value equal object at key. Key is E, so the value is 2. Is 2 an object? No. So we do 0 plus equals value, which is 2. So the sum is 2. We continue our loop, right? We continue our loop, so that means we're on F3. The key is F, so the value is 3. Is 3 an object? No. So we go into our else, and the sum is 2, as you can see. So 2 plus equals 3 is 5. Now we are done looping because we hit every key value pair. So after the loop ends, we return sum. So this function, sum vals of E2 F3, returns 5. Right? So if this returns 5, then over here we were waiting to add something to a 0, right? But now that that finally finished running, we do 0 plus equals 5. And the other thing gets taken off the call stack. So now that 0 plus equals 5, our sum is 5 in this situation, and we finished because that was the only key value pair, so we can just return sum from here, and since we return it, that gets taken off the call stack as well. And since that gets taken off the call stack, we were waiting for that to finish running over here so we could add something to our current sum, which was 0. So we add it to 0, and we bring that 5 back up, right? So this, the sum is 5, and since that was the only key value pair here, we can break out of the loop and return the sum, which is 5. Then, our original function call can finally unpause, because since this returns 5, that means this stops running, right? And if this stops running, that means it returns something, so that means these are the same, right? This returns this, so this is here, right? So 5 actually gets passed back up to the original thing. So we add that 5, because we're here, right? We add that 5, this is 5 now, to the sum, which is 1. So we get 6. And then that was our last key value pair, because there were only 2. We got the 1 from the A, and we got that 5 from going down into B, okay? So then we're done with that, so we return 6. And then we can take it off the call stack, and we get 6. It's not too bad, right? It makes sense. It's hard to come up with this, definitely, on the spot, for sure. If you've never seen this before, I wouldn't really expect any of you to get this, because it is very tricky. But it's important that you understand how it works when I'm explaining it to you, right? When you look at it, and we go through the call stack like that, you see how this works, right? If it's an object, just call the function again. But the whole thing is happening in a loop. Because you have to loop through the initial object, right? Any questions? Any final questions for me?
Last question.
Will we see
This is it.
questions that mix?
Huh?
Will we
What?
see questions that mix arrays and objects, like what you were saying earlier, or is that too advanced?
Maybe.
Really?
Uh,
Okay.
It's not too advanced if you think about it slowly and not panic.
Okay.
Well, we have time to think of slowly and not panic.
For the workshop you did. For the workshop you have forever. Yeah.
Can you have a helper function that does the recursive calling
Well, what do you,
side of your
a function that calls your function?
Can you have a helper function inside the original function and the helper function is doing the recursive calling? Is that allowed or not?
Well, what's the point?
So
Like you define your helper function that calls your function, but then you still have to just call that helper function that calls your function, right? So why not just call your function where you're calling your helper function?
no,
Right.
so
Like the helper function, like from last night, the is valid thing, you had a helper function inside of your function, but it wasn't doing any recursive call. You know? If you wanted that, I mean, you could do that, but you would have to pass down the function to the helper function. Or you don't if you define it inside of the function.
Yeah,
if it's
define it inside the function.
if it's
the helper function is inside.
Yeah, if you but like, I don't see any value for that, you know?
Because like with the numbers and the sums, like even if it gets, I mean, I guess maybe I just don't understand really how to write the logic properly. Like if you're, instead of adding sums, if you're trying to, if you have an empty array and you're like pushing things into the array and
Yeah.
it keeps getting reset, then like, but again, maybe it's just I don't know, right, the return logic.
Well, see, pushing into array is one thing, but I mean, pushing is concatenating pretty much, but mutating, right? So it would be the same thing. It would be like current array dot push the recursive call, right? Because you have to push in a value, right? And we know our function is returning a value. So if we just pass in the recursive call to push, then it would look fine. But like, there's no reason to do like a helper function that calls the recursive function, because if all your helper function is doing is calling your function.
No, your helper, I meant like if your helper function was the recursive function, like was doing the recursive in it, and then you just had stuff like
Oh,
variables.
get that out of your head. Any other questions on recursion? Any other questions?